Today, I will present how to create a chatbot using your data with OpenAI GPT. Let me start with some context about large language models, LLMs. These are vast models with billions of parameters containing extensive knowledge. They use transformer architecture, which powers modern generative models, capturing complex language dependencies. Essentially, they are intelligent statistical models that predict the next word or token. There are three main ways to utilize LLMs. First is the direct chatbot mode with prompting, where we simply ask questions to the LLM. This involves zero-shot or few-shot learning, where we might provide some examples or explanations to guide the model's responses. The second method is fine-tuning, which I discussed yesterday, a specialized training process to customize the model's behavior. Finally, there's RAG, or Retrieval Augmented Generation, which I recommend remembering as it's the standard term in the literature. RAG is a technique that involves augmenting an LLM with a private knowledge base. This is crucial because commercial LLMs like ChatGPT cannot answer questions about private data since they don't have access to it. In RAG, we enhance generation by first searching a private knowledge base called a vector database to add context to the prompt before querying the LLM to respond based on that specific context. RAG addresses several key limitations of LLMs. It reduces hallucinations, instances where the model confidently generates incorrect information, by providing specific context for responses. It also addresses the issue of frozen training data, as LLMs are static and limited to their training cutoff date. By connecting to a vector database, RAG allows us to enhance the model's knowledge and align responses with our system's requirements, which is particularly valuable in business contexts. The process works as follows. When a question is posed, a smart retriever searches the vector database for relevant information before the LLM generates a response. These vector databases operate differently from traditional keyword-based search systems or Elasticsearch. They process documents through embedding, breaking them into chunks, say 100 words each, and transforming each chunk into a meaningful matrix of numbers. When searching, we don't compare words directly, but rather the embedded versions of sentences using Cosine similarity to find the most relevant chunks. The process flow is user input, vector store query, retrieval of relevant chunks, prompt creation, combining template, question, and relevant information, and finally, model response generation. Various vector databases are available. For this demonstration, I'll use FAISS, Facebook's open source vector search database, which is perfect for our example. There are alternatives like Chroma, Quadrant, and Redis with vector capabilities. We also have SQL database plugins like pgvector and SaaS solutions like Pinecone. Elasticsearch has also expanded to support vector searches. We'll create a prompt template containing specific instructions, such as responding in French and limiting responses to questions about Farid Bellamech at Kung Fu. This helps control the chatbot's scope, preventing it from straying into unrelated topics. The template includes placeholders for the question and context from the vector database. For implementation, we'll use Langchain, a Python framework, also available in JavaScript, that simplifies the process. It handles document reading, chunking, embedding via OpenAI, and chain creation. Our chain will connect the model, GPT 3.5 Turbo, vector database, and prompt template. When a question is submitted, the chain retrieves relevant documents through Cosine similarity, combines them with the prompt, and generates a response. Langchain has evolved to offer a new approach called LCL, which includes semantic routing. This allows us to create routes for different types of content, Kung Fu, Farid, technologies, and embed them using OpenAI's encoder. The router determines which route is most relevant to the question, helping to limit LLM calls and reduce costs while ensuring responses stay on topic. OpenAI has also released their Assistant API, which offers similar functionality in a more integrated manner. It includes a knowledge base and additional tools like code interpreter and function calling. While powerful, it's currently limited to GPT-4 and can be quite expensive, potentially making it economically impractical for many applications. The main challenges with this technology include its rapid evolution, which creates stability in knowledge, issues, and the ongoing costs of LLM calls. Cost optimization is essential for making chatbots both efficient and economically viable. For organizations with data privacy concerns, using SaaS LLMs like OpenAI might not be an option. In such cases, open source LLMs like Mistral or Llama can be used, though this introduces infrastructure management complexities and GPU requirements. Despite these challenges, RAG represents a powerful approach to creating context-aware chatbots that can work with private data while maintaining accuracy and relevance. Thank you for your attention, and if you enjoyed this presentation, don't forget to like and subscribe.